Okay, folks, and the final part of Unit 3, which is volume and capacity, but this time of spheres, cones, and pyramids. So it's the same way. It's done the exact same way, right? Which is find the formula, plug the numbers in, and solve, right? It's done the exact same way as before. We just have some different formulas. And again, these are available to you on your formula sheet. This is printed out for you. You guys should have this, or it's on the what do you call it? On the LMS. Either way, though, I do recommend you guys have this always available for you. It's just easier than going back in the textbook sometimes, but it's here, and you can see there are the formulas here. All right, so starting out to find the volume of a sphere, how much can fit inside a sphere? It's this. It is 4 over 3 times pi times radius cubed. Really look at the 3 part here, right? The 3. So in terms of what that looks like, this is 4 over 3 times pi. I'll write that in a second. Times r times r times r is how this one works. 4 over 3 times pi times radius times radius times radius. So that's what this one is here. And again, know that 1,000 cubic centimeters is equal to 1 liter. Now, another thing that's going to come into play here is sometimes we need to convert things. So specifically, we know that 1,000 cubic centimeters is a liter, but how many cubic centimeters is a cubic meter or vice versa? That's a little bit different. And so instead, what I want you to think about here is I want you to think about this. So you have this box here, right? It's a meter by a meter by a meter. Now we know 1 meter is also 100 centimeters, right? So this box here is 100 centimeters times 100 centimeters times 100 centimeters. Now, if I were to times this just how the meters, so for meters, it's 1 times 1 times 1, right? Well, that's 1. But if I were to go to centimeters, it's 100 times 100 times 100. 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. That is a million. So 1 cubic meter. Oh my gosh, I need a mouse pad, guys. So 1 cubic meter is the same as a million cubic centimeters, right? So another thing to write down here. So 1 cubic meter is equal to a million cubic centimeters, or a million cubic centimeters is equal to 1 cubic meter. Make sure you guys write that down because that's going to come into play in this unit. So again, these are the same amount of space. So if I give you a box, a giant cube that is a 1 cubed meter, it's the exact same volume and capacity as a cube that is a million cubic centimeters. They are the same. So even though it's much, 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 much bigger, it's because we're multiplying these numbers together that it adds up to that way. So let's start here with a sphere. So first thing is, okay, it's a ball, it's a sphere. I know the formula for that. That is 4 over 3 times pi times r cubed. I'm going to show you how to do cube here. You could do r times r times r. That works. I'm going to show you how to do cube. Right? So please follow along your calculator with this. So it's 4 over 3, right? Fraction button, arrow key, times pi times, now the radius in this case was, the diameter is 0.2, which means the radius is 0.6. Now, how do I do this cube thing? I know how to do square, and you could just do this, right? You could just do it, but I want to, give you an easier way. So there's this little symbol here on the left side. It's a y to the power of x, a little x there. You click that, it's like put anything you want here. You want to put 8 here? You want to put 8.5? Sure. But you click that number. Again, I'll show you where that is here. It's right here, left side. Click that to the power of 3. 4 over 3 times pi times 0.6 to the power of 3. If I multiply that, so this is 0.9 cubic meters is the volume of the sphere. Now, what's the capacity of that? So again, I'm looking at meters. Well, a meter is, what's the capacity of it? Well, that's kind of tricky, right? This is actually kind of a tricky question. Your first instinct might be, well, maybe I'm going to convert this into this, right? I know this measurement, which you can, absolutely. But we also know other measurements. We also know, if I can find it. Again, this is why you have that formula sheet. I'll show you where that is in there in a second again. But we also know that 1 cubic meter is 1,000 liters. So why can't I just times that by 1,000? Right? Times this by 1,000, and that's going to tell me how many liters it is. So which is going to be 900 liters. I've got 900 liters in a cubic, in 0.9 cubic meters. So again, this is all available on here. So these are all put here for a reason. They are all used. All right. So now we'll find the volume each sphere. Here's a sphere. I want you to do it. So try and solve this now. Pause the video. 3, 2, 1, go. So you should have something like this, right? 4 over 3 times pi times 8.5 cubed. Oh, what did I just do? Pi times 4 over 3 times 8.5 to the power of 3. There we go. So it is 2,572.4. So 2,572.4. Point for what? Point for what? What is it? Centimeters, and it's volume, which means it's cubed. So you guys should be able to do this in this case. Just remember, it's a diameter. I'm going to trust you guys. You can do it. Now, this one here is kind of tricky. It wants us to find the space in between these two spheres, right? So the sphere, so this giant sphere has a radius of 43, right? So that's this line here. I'm going to actually color this green. So that is 46. Use blue. Oh, sorry, I've lied. I've made a mistake. So this, read the question fully before you start jumping into it, right? So this sphere is 46 centimeters, and the total of it is 76. And I want to try and find the space in between this. So I want you to think, how could you possibly do that? Once you do it, write it as that really easy formula. Like, for example, you remember before, oh, it's rectangle plus square plus triangle. Do something like that. All right. So what you probably should have figured out is that all I'm going to do is I'm going to take the big circle. So the volume of the big circle, I'm going to subtract the volume of the little circle, right? Because then all that's left is this space in between. So let's do the big circle here first. So the big circle, what's the radius? 76. So it's 4 over 3 times pi times radius to the power of 3, right? Which is 76 cubed. So all you got to do is write something like that. At a certain point, you can do something like that. I do recommend you write the blank formula still, but this is possible still. Again, this is still showing your work. Anything less than this, you would not be getting full credit for. But if you just do something like this means I know you know what the formula is. I know you know how to substitute it. But you still need to show something. So 76 to the power of 3. So it is, holy crap, 1,838,000. 1,838,778.4. Point for what? Point for what? Point for what? Cubic centimeters. So that's the one of the big circle. Now the small circle in this case, same thing. 4 over 3 times pi times the radius, which is 46. Four over 3. See how that fraction button's in handy for this? Times pi times 46 to the power of 3. And it's 407,720. 407,720.1 cubic centimeters. So now my main formula here was the big circle minus the little circle. I got the big one, I got the little one. So all I got to do is write that in, right? 1,838,778 8.4. Subtract 407, 720.1. 1838778.4. Subtract 407, 720.1. 1,431,000. 1,431,058.3 cubic centimeters is the volume of the space in between this. Like, when is this ever going to be useful? This is used all the time in stuff like nuclear power plants, for example, or for hazardous waste, or not waste, but hazardous materials, right? It's a buffer zone. What's the capacity? Well, I'm working with cubic centimeters. Do I know something where cubic centimeters can be used to find a capacity? Yep, 1 liter. So 1,000. So remember, 1,000 cubic centimeters is equal to 1 liter, right? So that's the case. How can I find this out? Divide it by 1,000. Boom, boom, boom. It's 1,431. We'll just leave it like that, liters. That's fine, right? There's the capacity right here. All right. So spheres, easy enough. Pyramids now. Now for pyramids, what we do is we just do, it's a 1/3 times the area of the base times the height. Now a pyramid has a rectangular or a square base. So it's actually 1/3 times length times width times height, right? So if we calculate the volume of this and the capacity, so 1, 2. The volume, well, we just established it's 1/3 times length times width times height. What's the length? 18. What's the width? 15. What's the height? Now I want to pay really close attention. The height is the true height from the base of the pyramid to the very tip of it. It is not the slant height. Okay? That's to find the surface area of a triangle. I'm trying to find, or of a pyramid. I'm trying to find the volume of a pyramid. Very different things. So I'm going to use the true height here of 25 centimeters. So, right, then all I got to do is I just got to go boom, 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 right? Multiply it all together. 1/3 times 18 times 15 times 25. 2,250. 2250. What? What's the units? Centimeters. And because it's volume, it's cubed. All right, awesome. Done? No, I'm not. Because the question asks for two things, right? Also wants the capacity. So you got to turn this into liters or milliliters. Well, we have that same thing up here, right? 1,000 cubic centimeters is 1 liter. Divide it by 1,000. Right, so boom, boom, boom. It is 2.25 liters of liquid that can fit in there. Circle that as well. All right. So you guys should be able to do all of these here. I trust you with it. I'll give you the answer here for the first one. This one's kind of a little bit of annoying. One thing to kind of keep in mind is this whole line here is 6.2. So you have pyramid 1 and you have pyramid 2. You got to add those bad boys together. I trust you to do that if you can do this. So I'll go over that. All right, question to let you guys do that. So 3, 2, 1. So you should have something like this for question 3A. If you can do this, there's no reason you can't do 3B or 3C. 3C is just an extra step, which is calculate the other pyramid and add it up. Oh, sorry. You know what? I've lied to you. This part's 6.2. This part's 4.8. My bad. Now for this one, you have a composite figure, right? You have your pyramid as the top part, and you have your rectangle, the volume of that at the bottom. So let's do this one here together. So starting out here, your pyramid. What's the so pyramid? What's that one? Oh, that's 1/3 times the base, which is length times width, times the height of it. Well, shoot, what's the height? It doesn't tell me. You got to read the question. The peak's 15 feet. Now, that said, I want us to be really careful here. I don't put 15 in here because I'm not measuring it from the tip to the bottom of the rectangle. I'm measuring it from the tip of the pyramid to the base of the pyramid, right? To this point here underneath it, which is, so if the whole thing's 15, this part of it is 9, right? It's 15 minus 9, which is this part is 6. So my height in this case is going to be 6. So it's 1 over 3 times length, which is 22, times width, which is 20, times height, which is 6. Multiply those together. Times 22 times 20 times 6. 880 cubic feet for the pyramid, right? That's the pyramid. Now we got to do the rectangle. Rectangle's pretty easy, right? Boom, boom, boom. We already have the 3 measurements, right? We have this from last time. It's length times width times height for rectangular prisms. 22 times 9 times 20. It is a total of 3,960 cubic feet. Now I'm not done because it wants us to add these up, right? Underline that, underline that. So in this case, the total volume is 880 plus 3,960. 4,840 cubic feet. Awesome. I figured out the volume. I'm done. Nope. No, you're not, because it wants the volume and the capacity. So you got to convert these into some kind of capacity. Feet. 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 We've never looked at feet before. This is where our formula sheet here is going to come into play. 30 centimeters is equal to 1 foot. So if I was smart about this, I would have changed all these into centimeters, right? So I would have done, okay, 20 centimeters. This one would have been 20. So if 30 centimeters is 1 foot, then that means 20 centimeters would be 20 times 30. This would be 600 centimeters. Now, I'm not going to do this. I'd have to redo the calculation again. But the important part here is read the question fully because we just made that mistake, right? I mean, I've done that on purpose, but it's reading it fully because who the hell knows what the capacity of a cubic foot is? We could figure it out, but we don't want to do that. That makes it harder for us. So just something to know. So I'll get you guys to do this. You're able to do this. You're taking the pyramid, taking the rectangle, and then finding the difference, right? So let's imagine, I don't know if it's the case, that the pyramid's bigger. You subtract that. You subtract the rectangle from that, or vice versa, the difference between them. For this one here, you'd have to use Pythagoras to figure out the true height. We don't care about that right now. Same thing. Don't care about that. Don't care about that. Don't care about that. Don't care about that. All right, and final one here is cones. Cones is the volume is equal to 1/3 times the area of the base times the height, right? So if the base is a circle, right, because it's a cone, right, that's a circle. Well, I know how to find the area of a circle. That's just pi r squared, right? So I just replace that with pi r squared, which means my actual formula here is 1 over 3 times pi r squared times height. So if I have you a cone with a radius of 3.2 and a height of 6, how much water can it hold? Well, it's 1 over 3 times pi times r squared times h, right? Just for the sake of space, I'm kind of keeping it condensed. So 1 over 3 times radius. My radius is 3.2, so squared, times height, which is 6. 1 over 3 times pi times 3.2 times 3.2 times 6. And it is going to be equal to 64.3. All right, so the answer here is 64.3 cubic centimeters. That's how much water it can hold. Nope, that's not how water works. Water, milliliters, right? Liters. So I know 1,000 cubic centimeters is equal to 1 liter or 1,000 milliliters, right? So all I got to do is convert this into 64.3 milliliters. So this is what the actual question's asking, right? So in this case, I'm going to do question, I'll help you out with question 7 here. So make sure you guys do this. So try this out. Try out question 7 here on your own. 3, 2, 1. And you should end up with a final answer of 379.6. 379.6 cubic. These are inches. Now, it only asks you to find the volume and not capacity, so we're done. So I'm going to trust you guys to do this. Not too worried. You guys can get it done, right? For these ones, you're just adding up two shapes. You're more than capable of doing it at this point. This is an algebra one. We don't care about that. This is a Pythagoras one. We don't care about that. So you guys now should be able to do all of these questions here, except for question, I believe it was 6. Yeah, except for you're not doing question 6. Wait. Hold on, where am I? Oh, I'm at the wrong one. Okay. Here, I'll go through it and let you know. So give me 1 second here. But anyways, do your stuff, do your assignments. All right, you guys are more than capable of doing everything in here. So finish off the practice questions, finish off the chapter test, and then you're done this module. Good job.